Hello and welcome to Educated STEM. I am Kate, the founder of Educated STEM, and I'm going to make a couple of different videos right now which are going to address some of the issues that are happening when it comes to science and research in the United States at the moment, and how that might affect the rest of the research that happens and how that will then impact cures and treatments along the way. So the first thing I want to talk about is, what are the National Institutes of Health? What are they? And I know if you're watching this, you're like, Kate, I'm a scientist, I already know. But this is for everyone else who may not know. So if you're watching this and you do know, then please continue watching. You might learn something new, but also share widely with other people who may not know this information. So the National Institutes of Health, also known as the NIH, is a national department or institution that has a mission to seek fundamental knowledge about the nature and behavior of living systems and the application of that knowledge to enhance health, lengthen life, and reduce illness and disability. So that's a great mission, right? And they have 4 separate goals, which are: 1, to foster fundamental creative discoveries, innovative research strategies, and their applications as a basis for ultimately protecting and improving health. Sounds good? 2, to develop, maintain, and renew scientific, human, and physical resources that will ensure the nation's capability to prevent disease. Again, cracking. 3, to expand the knowledge base in medical and associated sciences in order to enhance the nation's economic well-being and ensure a continued high return on the public investment in research. That's a key one. And the final one, 4, to exemplify and promote the highest level of scientific integrity, public accountability, and social responsibility in the conduct of science. So that is the mission and the goals of the NIH. Now, how do they do that? So they actually are broken up into 27 research institutes and centres which have very specific focuses. So the research that I used to perform, the research funds came from the National Cancer Institute, or the NCI. I think you can probably guess that they do cancer research, or they fund cancer research. Then all of the other institutes also have very self-explanatory names. So we've got things like the National Eye Institute, the National Institute of General Medical Sciences, the National Institute of Diabetes and Digestive and Kidney Disease. So that's a kind of a mouthful. That's like 3 different areas, but for one institution or institute. And in these institutes, they perform research. So they have sites in Bethesda, which is just outside of Washington, D.C., and it's a really big campus, and they have these big buildings, and there's cutting edge research that is done in there every day. And so they have students, they have postdocs, they have staff scientists, they have professors or group leaders, principal investigators who are doing all of the research. But they also give out money to people outside of there, so in universities and research institutes, to fund the research. Now, in order to get your hands on this money, you need to put in an application. And there are many different grants that you can apply for at many different levels. So if you're just beginning your career, there are certain grants for you to apply for as an early stage career person. And then there's ones which are for people who are more established. There's ones for institutions that they can apply for. So it really does depend where you are in kind of your career for what you would be applying for. A graduate student would not be applying for an R1, which is what you'd be applying for as an established scientist. So you have to apply for the grant that you are eligible for. And so you spend an awful long time writing these grants. It takes a very, very long time. And then they are sent off, and a program officer is in control of a particular area. They will collect them all, and then they will arrange a study panel. And so they ask scientists who are well known in their field, who are experts, to review all of the applications, and then they generally go to Bethesda and meet in person, and they talk about all of the grants and decide who gets the funding. Now, I will say that all of the scientists who do these panels or committees are not paid for it. They are giving up days of their time in order to ensure that the research that goes through is of the highest quality. They want to make sure that it's answering good questions. So I know that you may have seen things about, the nonsense research that is being done by the NIH or funded through the NIH, and that simply isn't true. Someone who is an absolute expert in that field has decided that the research that is proposed is a good idea. It has a great rationale, that they have the expertise in order to complete the research, and they have approved it to go on. And not everyone who applies gets the funding. It's a lot of people, the majority of people get rejected. So it's not like the NIH is willy-nilly handing out money. That just doesn't happen. So when it says, or people say that the NIH is wasting lots of money, it simply isn't true. All of those people who work in the funding area are experts. They've got PhDs. They know what they're doing. They help the scientists who do the reviews to ensure that the best proposals get funded, and then the funding happens. And then once the research starts, they have to tell the NIH what their progress is every year. Every year, a report is written detailing all of the progress that they've made, showing how much money they have spent. So you have to constantly tell them what you're doing and kind of prove that you're spending the money correctly. And if you think, someone at the institution might be spending the money in a bad way, well, there's someone at the institution whose job it is to make sure that the funding is spent appropriately. And when they do that, they actually have to attest that the research is being performed properly, that the correct things are being bought on the correct grant money. And if they don't do that properly, the individuals and the institution can get into a lot of trouble. So the people who are coming up with these things saying that the NIH spends money badly are just not familiar with how research works. And it would be great if people would take the time to learn how science and research happens in America, because then these things could have been stopped right at the very beginning, a couple of hour meeting, and we wouldn't be having this problem. So, the idea that the NIH needs to have cuts because they have been spending money poorly is just not true. So let's talk about money. So for every dollar that funds the NIH, it generates $2.46 of new economic growth. So it fuels the US economy. That, for every bit of money that we spend, we get more back. And so in fiscal year 2023, 47 states had over $100 million in funds. 31 states had over $500 million in funds, and 23 states had over $1 billion. That's a B for billion, not a million. So that is a lot of money. So I live in California, so let's talk about some numbers for California. So California gets 5.31 billion with a B in NIH funding. That shouldn't surprise you. Obviously, we have amazing research hubs in San Francisco, San Diego, and LA. So we have a lot of fantastic institutes and universities that are performing research. So it supports 55,949 jobs and supports economic activity to the tune of 13.5 billion with a B. So that is a lot of money. And so we're getting some money from the NIH, but we're also generating things, because every time the research gets done, things get patented, it generates cash flow into the economy, which is obviously a good thing. Now, I've seen people say that it's okay if they cut the money from the NIH or the NSF, which is the National Science Foundation. It's okay because other funding sources will come in and fill holes. So we do get an awful lot of money from other things like the Howard Hughes Medical Institute is a big one. If you do cancer research, Susan G. Komen does breast cancer research. There's things like the Burroughs Wellcome Fund, Bill and Melinda Gates Foundation. There are other foundations that you can get their money from to do research, but they're not going to be as large. They're not going to be getting as much money as you get from federal funding, so either the NIH or the NSF. And it needs to be money from a federal source if someone's going through their career in order to progress to the next level. Because I have known individuals who've had lots of money from individual donors or from foundations, but because it wasn't federal money, it wasn't from the NIH, the NSF, they didn't get to move up to the next level of the career rung because they had the incorrect money. So stopping people from getting these funds at any point during their career can actually lead them to stop their career because they can't progress any further, because unless the committees that decide if they can get promoted or not take into account this potential freeze, then they're not going to be allowed to progress, which, if you can imagine, doing your graduate studies, if it's in America, will take you at least 5 years. A few postdocs could be 2 to 4 years or more. And then you go in as a junior professor or an assistant professor. So you're looking at 9+ years before you even begin to go through the hierarchy of professorship. That's a lot of time to invest, and then for it all to come unstuck because you cannot get funding because your grants are not getting reviewed, because they have stopped the grant review process. And they've even taken some of the grants off the website. They're no longer showing, so you can't apply. So people who've already applied don't know if their applications are going to be reviewed. So it's going to cause a lot of damage to a lot of scientists in their careers, no matter where they are. But it's absolutely going to affect the people at the lower level, so the graduate students and the postdocs who are relying on these funds in order to do the research to then hopefully progress through the career track. And so thinking that these other research federations or foundations will come in and fill the hole is incredibly naive, because an awful lot of them have already started thinking, the government or whomever is making these decisions, and it might badly affect them if they don't change the way that they're doing it. So to put this into perspective, the Howard Hughes Medical Institute is the nation's largest private funder of biomedical research, and they have cut a $60 million program called Inclusive Excellence Program, which was aimed at making universities' STEM, so that's science, technology, engineering, and maths, education more inclusive. So they've cut it, it's gone. And they've also gone ahead and changed their wording for 3 programs that sought to advance scientists of color and from other underrepresented groups. So that is and I might completely mispronounce these, so apologies if I do. We've got the Gillian, or maybe Jillian Fellow, the Freeman Hrabowski Scholars, and the Hannah H. Gray Fellows. So any of the wording that was in those fellowships around being committed to advancing diversity and equity have been changed, and instead it focuses on inclusion and excellence. So the largest foundation that could potentially fill in some of these gaps has already changed the way some of their funding is going to be given. So you can't just assume that the funding deficit is going to be made up by other people and that you can continue as if whatever is happening at the NIH and the NSF doesn't matter. And I also want to talk about the fact that people seem to think that the topics that are being researched might not lead to important discoveries, or they're a bit silly. So I've definitely seen some tweets where people are like, oh my gosh, they're doing research on poop. Now, if you actually look at what the research study that they're looking at is, it was to try and develop a technology that would look at your poop actually whilst you go to the loo and you're on the toilet to see if you might have colon cancer. And having had a lovely colonoscopy, I can absolutely say that if I could go to the loo and the loo would tell me, oh, Kate, you probably need to go and see a doctor because you might have issues, that would be so much easier than, being put under and having the procedure and other things. So it's not necessarily a silly research project, but I'll give you an example of one that if it was done today, I think they'd be like, this research does not pass go. And so in the 1980s and the 1990s, and this happened in Canada, so props to Canada, there was a scientist who did research on Gila monsters. So that is a big lizard. And Gila monsters can survive for long periods without food because they can slow down their metabolism and sustain stable blood sugar levels. So what has that got to do with research? So through researching on the lizard, it led to type 2 diabetes drugs like Ozempic and other GLP-1 drugs, which is a glucagon-like peptide drug, which have gained lots of publicity recently because they are used for type 2 diabetes patients, but they're also used as a weight loss drug. Also, they might also be used in the future for other diseases. So currently they're looking at Alzheimer's disease, addiction, and heart disease, but maybe those will be increased and more diseases will be looked at. But I can just imagine one of the people who are reviewing the research right now, if they saw that, right now they'd be like, oh my gosh, who wants to look at lizard spit or the enzymes in their digestive system? That's silly. And yet, look at the things that are doing right now in diabetes and also weight loss. So you can't look at the research if you don't understand what the research is meant to be doing. Then don't assume it's dumb. Just because it might be very complicated. Someone who is an expert in that field has decided that it's good. It's a good idea. So I know it's hard to trust scientists sometimes, but please, we do know what we're doing. And so the final thing that I want to talk about when it comes to the NIH is the fact that they want to reduce the amount of money that universities and institutes can collect for something called an indirect cost. So what is an indirect cost? So when you get your money from the NIH, for example, they will give you a certain amount, and that is for potentially your and other people's salaries, and also the reagents or equipment or whatever it is you need in order to do the research project, which is fabulous. That is what we need. That's great. But it also doesn't include the other things that you need in order to do research. It doesn't keep the lights on. It doesn't pay for the electricity. It doesn't pay for your air conditioning or your heating bill or your water bill. It doesn't pay for all of the other people that are absolutely required to make sure that your research goes well. So people who are looking after the money and making sure that it's spent appropriately, people in the grants office who help you write documents and other things, administrators who make sure that you're going through all of the appropriate protocols, and if you need approvals from someone because you're doing research on humans or animals or something else, that you've jumped through the correct hoops and it's all signed off. So all of these things are absolutely necessary in order for research to happen. So the indirect costs actually go to supporting all of those things. So also if there's shared research facilities, so maybe there's a microscopy suite, or something else that you need, the money goes towards them. And it's vital. It is absolutely vital. So every few years, you actually negotiate with the NIH how much your indirect costs can be. And each time you do it, you have to justify why you need that much money. And that is why different institutions have different amounts of indirect. So here you go. Indirect rates can range from 15% all the way up to 70%. And that's because the institutions renegotiate their rates every 4 years, factoring in the components, like whether they need equipment, whether they need operations and maintenance, library expenses, things like that. So that is why the amount is different for each institution. And I've also seen messages about, well, they've got all of this money, so why can't they use this money to kind of fill in the gap? So yes, they do have an awful lot of endowments, that is true. But that is not the way an endowment works. An endowment has been a donation to the university or research institute, which will have strings attached. So just to put these very simply, if I were to give $1 million to a research institute and said, okay, this is the Kate amount of money, I need you to take this money and only perform breast cancer research on it, then that is what they have to do. They cannot use the money for other things. If they do, I can ask for my money back, or I can sue them, or do different things. But I've given them $1 million. They're not going to take that $1 million and spend it. That is going to be looked after. You do not usually go into the seed money, and then they're going to take the interest or any money that is earned from that million, and they're going to use that in order to do the breast cancer research, because that makes sure that they will have money every single year because the principal is still there. So yes, a lot of these universities have an awful lot of money, but those gifts have strings. So they can only use the principal or the interest that is generated. But they can also then only use the funds for whatever it is that the donor requested. So whether that's a particular kind of research, or to pay for salaries or stipends for graduate students, postdocs, professors, whatever it is, the institution needs to use that money in the way that it was intended. So they cannot just go into their endowments. But the indirects also don't cover all of the money that they need. So institutions do have to raise money in other ways. So whether that's patents that they have, or from other donations or other things. So in 2023, colleges and universities contributed approximately 27 billion with a B of their own funding to support research and other things. So just because they're getting indirects does not mean that covers the entire research enterprise, but it does, I hope you understand now, why the indirects are so important, and they get renegotiated every 4 years. So cutting it down to 15% is going to have a massive trickle effect on all of research and other things. I already know that some institutions have either decided that they're not taking graduate students this year, or they're reducing the number of graduate students this year. They are worried about how their research is going to get funded, because if the NIH and NSF are not reviewing grants, then there's going to be a major funding shortfall. So that might then impact job stability in universities and institutions as they look to make cuts in order to remain afloat. So it is very, very important that we get the funds through. So the NIH and the NSF continue to look at their grants. You trust that the people who are asked to sit on these review panels are the absolute experts in their field, and they will make good decisions and be good stewards of the money. And so just to put this into perspective, if you cut the research support, so we're cutting that money, it's going to harm the institutions in those states. So for example, Texas institutions would face a reduction of $310 million. Institutions in Iowa will have a reduction of nearly 37 million. And California, which just has a massive research enterprise, would lose more than 800 million. And that's just in the indirect costs. So that is a crazy amount of money to lose because people haven't taken the time to learn about how research is performed and where the money comes from. So I'm going to finish this with a quote from President Barbara R. Cinder. I think that's how you pronounce her name. Sorry, Barbara, if it's not. Who is from the Association of American Universities, and her quote is, Facilities and administration costs, also referred to as indirect costs, are real and necessary costs of conducting the groundbreaking research that has led to countless breakthroughs in the past decades. A cut to F&A reimbursements for NIH grants is quite simply a cut to the life-saving medical research that helps countless American families. Now, if you remember at the very beginning of this video, one of the points that I mentioned was the third goal of the NIH, to expand the knowledge base in medical and associated sciences in order to enhance the nation's economic well-being and ensure a continued high return on the public investment in research. So by cutting off those funds, it's harming the entire research enterprise. So you're not going to be getting the cures, you're not going to be getting the treatments. And the one thing that I think you need to consider is people might think, oh, it's okay, pharmaceutical companies will step up to the plate and do more. And pharmaceutical companies do research, that's awesome. But they also buy smaller companies. And so say a university or a research institute has a great piece of research and they patent it, and then it becomes a very small company, and that company shows promise, then eventually one of the big pharma companies is going to take notice. And the easiest way for them to benefit is to purchase the company. And so that's not going to happen. If the research isn't being done at the university and research institute level because the money isn't there, then big pharma isn't going to be able to come in and scoop up these companies, and then you're not going to get the treatments and the cures. So everything is just coming back to the same point. We need the NIH, the NSF, federal funding to be approved. We need all of the money flowing in and making sure that the research that can happen in America can continue. Otherwise, we're going to lose an entire generation of scientists because they might lose their jobs. Some already have at various research institutes. And people who are considering STEM careers are going to just look at this and think, oh my gosh, that does not look like a stable or fun career. I don't want to take the risk. I'm not doing that. And they're going to go off in a completely different direction. So let's stop harming the career STEM pathway, pipeline, and let's stop harming research in general in America, and hope that everyone can continue and do it. So thank you for joining me. Please share this with non-scientists so that they can understand the importance of this, and they can also then help advocate on our behalf. So thank you for joining me, and I will see you next time. Thank you. Bye-bye.